what's going to be the next step we can do using AR or augmented reality? We will talk about that with an artist, technologist, and designer, Jody Medich. Welcome, Jody. What do you do if I do? These are not the droids you are looking for.
Well, I'm immune to the Jedi mind trick.
You are immune. Where are you from?
Yes. I told you, I'm from Detroit, you know.
Really?
We have special abilities, yeah.
So you are immune to the Jedi trick?
Well, I'm a Jedi myself.
Oh, really?
You will let me give this talk, yeah?
The floor is yours.
Thank you. Hello again. Good to see you today. So today what I'm going to talk to you about is not gene editing or human editing or even cutting into human bodies. Instead, it's how we can leverage technologies like extended reality to create superhumans. And by that I mean to say that we are excellent now at making supercomputers. We've been doing it for about 100 years, really. Now is the time to stop focusing on the technology and start focusing on what it does and enables in humans. Now, extended reality is a kind of a tricky term. A lot of people have different definitions of what XR means, but I mean it as extended reality. And when I say it, I refer to this suite of technologies that you see here. Now, these devices describe a continuum of immersion, from mostly real on the left side to fully immersed in virtual reality, and some spectrum in between, okay? And the reason it's so important for us to start to think about extended reality and its impact on humans is that Satya Nadella, the CEO of Microsoft, says that there are 3 technologies that are going to shape our future: artificial intelligence, quantum computing, and extended reality. Tim Cook says that all of your devices are going to be replaced by extended reality by the year 2021. Okay? I know, I hear a lot of mumblings of, come on. Why is this happening? Well, the world is dematerializing very, very, very rapidly. It started in 1984 with the invention of the desktop computer, and since that time, all sorts of things have started to disappear into our computing devices, right? It started with calendars and spreadsheets and documents, and then 1994 we had the advent of the internet, and suddenly stores started to disappear, and communications just started to disappear, and our social networks started dematerializing into our devices. Then came 2006 and the advent of the iPhone, and suddenly books disappeared, and music disappeared, and tape measures, and calendars, and maps. My doorbell seems to have disappeared into my phone. People don't actually ring my doorbell anymore. They just text me when they're there, and my dog starts barking, right? That's how quickly our world has been dematerializing. In fact, by the year 2019, by the end of this year, we will have developed 44 zettabytes of data. Anybody know what a zettabyte is? Yeah, I thought not. It's an irrational, oh, hey, 2 people. It's an irrational number. 44 zettabytes is 2 stacks of books from here to Pluto. That's how much data we're talking about generating in this year alone. Now, we are no longer limited by manpower. As I talked to you about yesterday, we have all these robots and all these things that can amplify our manpower beyond what we can accomplish individually. Today, we are limited by brain power. We are limited by the ability to make sense of all that data that we're generating. Now, we created a tool to help us do this. It's called artificial intelligence, yeah? Artificial intelligence is designed to be an upgrade to our neocortex. Your neocortex is the part of your brain that recognizes and makes sense out of patterns. Now, AI gives us the promise of upgrading it from the 300,000 patterns that we can naturally recognize to upwards of 2 trillion. And once one of us learns a pattern, all of the rest of us will benefit as well. That's the promise of AI, that it will amplify our brain power exponentially. Unfortunately, if we look at the way that we currently use our devices, our human-machine interface, it is actively killing our brain's ability to function. This is why in multiple studies we're noticing that adults are experiencing a very staccato way of thinking, meaning these little bite-sized little pieces, right? And that's really killing our brain's ability to do that deep, cognitive, creative function that it's designed to do. The problem starts with our interface, right? The method that we use is called GUI, Guided User Interface. It was developed back in 1973 at Xerox PARC and later perfected by the Apple Macintosh that you see here, which was released in 1984. Now, back in 1984, the amount of data individuals had to deal with was 5 kilobytes. 5 kilobytes is not even a grain of sand compared to 44 zettabytes. And the way it was designed is that we use images and text to basically shortcut our need to understand command line languages. Okay? So that's what it was developed to do, and it was always thought of as the first step in human-machine interface. But instead, it's what we have relied on for over 30 years now. It's designed to be used while you're seated at a desk, right? Because most of the tasks that you did back in 1984 was to type on a typewriter type device. So you were writing documents, you were doing spreadsheets, you were doing math, all of which are great while seated at a desk. But now, we take our devices with us everywhere we go, right? All of you right now have your computer in your hand or on your lap. You might even have 2 or 3 of them with you. We take them on airplanes. We take them to the beach. We take them out for dinner with our families. We take them all sorts of places. And if you think about it, that's a lot of information that we're looking at on really tiny screens. So for example, GPS, right? GPS we take with us everywhere. In fact, everywhere I go, I have my GPS, just in case I get into a traffic jam or I want to go someplace I've never been before, such as when I tried to go around this roundabout in England, okay? Now, looking at this on a big screen is still a lot of information that you have to pay attention to, right? There's so much information on here. And to make matters worse, you're usually looking at it on a little tiny screen that's not much bigger than this clicker that I'm holding. And you're using it in situations where either you have no idea where you are or you're in a stressful situation like a traffic jam, right? And so in this situation, here I am driving on the wrong side of the road in busy traffic, not quite sure where I'm going, and I'm heading into a roundabout, which I don't have those where I live, so I was really confused, right? These are all situations where I really should be paying attention to the road so that I don't hit that motorcycle that's coming at me. But instead, I'm splitting my attention between the road and operating my device. So I'm not just driving. I'm also operating a device. That means I'm doing 2 tasks, not 1. And I have really bad news for all of you. We're all terrible at multitasking. So bad at it, right? The minute we add one task to another, we reduce our ability to do either by half, yeah? In fact, fighter pilots, people that are really good at multitasking, if they can do 4 tasks at the same time, they're considered super abled, like astoundingly so. So you're fooling yourself if you think that you can watch TV and actually do some work or, say, play with your kids and also check your emails at the same time. You are incapable of multitasking at that way. And that's why we end up in these types of accidents, right? The issue is that we have very limited working memory. That's your short-term or your task-based memory, okay? And it keeps track of any sort of activities for a given task in a given context, right? And the minute that you switch activities or context, your brain wipes out that short-term memory and allow you to be able to focus on this new context and this new set of tasks. Right? It's often called the doorway effect. Now, I'll give you an example. You're sitting on your couch, you're cold, and you think, aha, I'm going to go to my bedroom and I'm going to get a sweater. And you walk through that door into your bedroom and you go, wait a minute, why'd I come in here? Right? It happens to all of us. It's normal. That's the doorway effect in action. What has happened is that your brain was paying attention in the context of sitting in on a couch, and then when you walked into that bedroom, it said, oh no, new context, and it wiped out all of that task-based memory. Okay? And that's why it's called the doorway effect. Now, this type of interruption, whether it be an actual doorway, a virtual doorway such as moving between tabs on your browser or switching between applications, doesn't matter. All of those are the same proverbial doorway, and each interruption costs you anywhere from 0.3 seconds to 30 minutes to get back to whatever it is you were doing. And to give you an idea of the size and scope of this problem on humanity, you check your phone 2,600 times a day. That's 2,600 times a day that you're doing something really trivial like, I'm going to see my text messages. I'm going to check the time. I'm going to check the weather. You are interrupting yourself 2,600 times a day just on your phone. That doesn't include all the times you're being interrupted in deep tasks while you're operating your computer. Now, the problem is not the data. It's not that we're getting all this amazing amounts of data, because our brains are actually really good at processing data. It's what's allowing me to stand up here and walk across the stage and blink and breathe all at the same time. I know, I'm fabulous. I can't believe it, right? But the thing is that actually this type of movement helps me to process thought way better than if I were to sit still, right? How many times have you been stuck on a problem and gone for a walk and suddenly, aha, I have the answer, right? It's because when we engage our body in thought, we amplify our brain's abilities dramatically. So it's not that the data is the problem, it's the way that the data is being delivered to us. The problem is the delivery. Our reliances on this image and text interface is a problem because that's not how our neocortex works. It's not a dictionary of pictures and images, or text, right? What our brain does is it uses our senses and movements to make sense of the world. That's how we take in data. And there's different parts of the brain that are designed for different functionality, right? There's part of my brain that processes sight, smell, sound, movement, all of it. So what we need to do is figure out how to talk in that native language to our brains in order to amplify the brain's functionality. The good news is we already have a practice for this. It's called ergonomics, right? This is a familiar term. Ergonomics is basically adapting a system to match human physiology in order to amplify our output. The most familiar to you, of course, is physical ergonomics. Physical ergonomics amplify manpower. It's like I was talking about yesterday with the exoskeletons, right? This is a glove developed by NASA and GM that's a robotic hand that I put on as if it's just a glove on my hand. And this is how I operate it. It doesn't require any, multitasking. It's just one task. And now with the effort it takes me to lift 5 to 10 kilograms, I can lift 15 to 20. And I can have amazing amounts of repetitive actions without ever getting tired. And that's because we've adapted the robot to match my physical ergonomics, and that amplifies and extends my human ability beyond my individual capacity. In the same way, we can apply ergonomics to your brain. It's called cognitive ergonomics. This is an emerging field that looks at how to amplify the human brain ability within a technological system. Okay? And what it does is that we take data and we translate it into our native brain format of sensory and movement, okay? So that's what it does. That's all it does. It's super simple, and it works impressively. Now, XR is the perfect tool for this for several reasons. But most importantly, it's because it provides a main line of sensory data directly to your brain in the form of vision. The way it does this is simple. For starters, your visual cortex is really important to us as humans. In fact, it's a ginormous part of your brain. If you take your hand and you put it on the back of your head, it's okay, try it. Nobody's going to laugh. Right? That's the massive part of your brain. And it's implicit in both halves of your brain, not one or the other, but it works on both sides of your brain. And it's involved in nearly 85% of your brain's functionality. 85%. That's like almost all the function of your brain, and it's all using this visual data. Now, what XR does is it takes the screen from across the room and shoves it right up against your face. So now you're basically mainlining the visual data from the computing system. And it's so convincing to your brain that you don't understand what's happening, right? That's why we fall over in XR. Because what's happening is that your brain uses vision to triangulate all of your other senses, from touch to smell to taste, everything, right? And if whatever you're seeing trumps anything else that's happening in the world, right? So that's why people fall over, is because they cannot differentiate between what they're seeing on the screen and what's actually happening in the real world. Now, it's so powerful, so impressive, that we can use it to transcend pain. Right? So researchers at Washington's HIT lab, they were working with burn patients returning from the Iraq War. Now, these patients had burns over nearly 85% of their body. They were in such bad, terrible, excruciating pain that morphine only reduced their pain by 20%. That's nothing. So what these researchers did is they created this VR game that you're seeing here, where first things first, you're immersed in this icy wonderland. So the brain says, that's not burning, that's cold, I'm freezing, okay? And then they distract the patient by having them throw these snowballs at these poor little penguins and snowmen. And for some reason, you're listening to Paul Simon music. I don't know what that's about. But this tool reduced pain by 60%. Morphine 20, VR 60. No drugs, no surgery, just VR. And what's even more impressive, after 2 months of using this tool, they train their own brains how to call up this visualization. So they no longer even have to wear the VR. If they're having an excruciating pain moment, they can just kind of close their eyes and pull up this visualization and get that 60% reduction in pain. So the brain is learning how to heal itself. Now, why haven't you heard about this before? Well, this is back in 1993. 93 we made this breakthrough. Why isn't this everywhere? Well, in 93, this was the state of the art of headgear. I can't even set this up, right? And I've been working in this field for over a decade. Okay, there's no way I could set this up. And the cost of this was somewhere around $70,000 for this piece of headgear. And it was pretty bad. It was not the best technology. Today, each and every one of us can buy an Oculus Go for US $199. The price went down so astronomically, and the quality is so much better than that crazy $70,000 piece of equipment, that now we're not having to worry about developing the devices. Now we're just creating applications that run on the devices. And that's a much easier thing to do. So much so that groups like Cedars-Sinai Hospital in the US are running clinical trials on something they're calling Pharma VR. And they're using virtual reality to treat all kinds of things from pain to depression, anxiety, all sorts of things. MS, stroke, all these things are being treated in VR dramatically more effectively than any existing medical procedures. Now, that's not all. That's just one aspect of VR. The other thing is that XR adds space to computing. Why is that important? Well, that visual cortex I told you about is part of a larger system called your spatial cortex. That's the part of your brain that's creating a spatial map no matter where you go. You're not even conscious of it. Right now, you can tell me where the door is to this room without having to do some sort of search on your computer. You just turn and look. You know where it is. And if I were to ask you to sit here and imagine sitting on your bed at home, you could easily point to where the door is in your bedroom. Okay? That's our spatial cortex. And it's so important to us as humans that we have evolved over the past 100,000, 200,000 years to use it very effectively, to offload tasks from our working memory. Okay? It's so much so that Mary Zawinski of Microsoft Research says spatial memory is free. And what she means by that is that we use it to do all sorts of things, from understand the difference between objects based on their dimension. We use it to remind ourselves to buy milk. I use it to remember where my keys are, as long as I put the keys in the right spot in my house, yeah? We can tell the difference between, say, item 1 and item 2 based on an alphabetical list or a timeline. But most important for what we're talking about today is that space helps with multitasking. In fact, space improves productivity upwards of 40%, because now you can move between tasks just like this, instead of having to move between doorways to go from one task to another. No more context switching. It's all in the same field of view. Now, XR adds that important space to computing, that space that's sorely lacking on our magical pieces of paper on a screen, okay? And that means that it improves multitasking upwards of 40%. Because now we have infinite space to lay out our task and to understand what's happening within that space. It also dramatically aids in data comprehension, okay? Because now I can look at my data using spatial metaphors to understand what's happening at a glance. And speaking of those workers that are aging out that I mentioned yesterday, interfaces like this, which is a cybersecurity tool, allow them to hire digital natives who are great at playing video games to patrol their data, as opposed to having to hire and train very expensive data scientists. Right? So this helps us get past that skill gap. There's a great article on this, by the way, on Singularity Hub, written by my colleague Aaron Frank, that I highly recommend you check out. Now, all of this means that XR amplifies our brain power, just as I suggested. Right? So we can use it to rewire the brain, such as my friend James Blaha here. He had a lazy eye, which means his brain wasn't paying attention to one of his eyes, so it kind of drifted in the socket. Now, unfortunately, after age 12, we always thought that there was nothing you could do if you had this kind of affliction, or if you had a stroke, or if you had MS. Your brain is wired the way it is, nothing you can do about it. But what happened is that he created this game, and it sends one piece of data to one eye and slightly different to the other eye. So the brain started to pay attention to the lazy eye again. And now he could see in VR, in full 3D. His brain started paying attention to that eye again. And then when he took the headset off, he could also see in 3D in the real world. So he proved that VR can rehydrate neural plasticity, which is really powerful when we think about issues such as paraplegia, right? So XR plus movement gives us amazing superpowers because it allows us to leverage digital data as if it's our own. So in the Walk Again project, they took 8 paraplegics. These are people that lost control of their legs through some sort of spinal injury. Okay? And what they did was they put one of those EEG caps that I showed you yesterday that woman was wearing. So this is on their head, and there's a particular sensor, it's outside, right? And there's a particular sensor right about here. and that's on your M1 cortex, your motor cortex. And it's the one that controls leg movement, all the movements in your body, really. But this right here controls your leg movement. So I don't have to think, leg move, leg move, leg move. It just does it, right? It's an instinct. So they put a sensor right there, and they attached it a pair of avatar legs, VR legs, okay, that would now, the paraplegic was trained to control those pair of legs just like I control my leg right now, okay? And then, once they got good at that, they added an exoskeleton to the mix. So now I'm seeing my legs move and I'm feeling my legs move, right? So I'm matching the visual and the physical together into one. And after about 6 months, all 8 patients started to regrow the musculature and circulatory system necessary for walking. And after about a year of this treatment, they all had voluntary leg movement back in their rooms without any of the apparatus on. What happened? Through the use of VR and motion, the brain had created a new neural pathway to allow them use of their legs again. This is astounding stuff. And this is coming to a store near you really quickly. So XR allows us to update HMI to live in this new data landscape that we're living in. This data that I told you about that we're able to pull out of ourselves, manipulate, and shove back in the way that we were talking about CRISPR this morning and some other technologies, right? XR puts the human squarely in the loop of AI and robotics and all of this technology. Because number one, you look through the screen and not at it. And this improves our productivity upwards of 35%, just by that one little act alone. Then, not only are you looking through the screen, but so is a whole suite of perceptual computing devices. Things like machine vision, emotion sensing, brain sensing, you name it, we can put that on the headwear. And that means you're no longer having to stop to focus on the device and the task. You just focus on your task, and the device takes care of the rest, right? So we're no longer having to translate our world. We're no longer having to walk through doorways over and over and get that interruption over and over and over. So what happens is that this technology basically amplifies and extends human abilities, just like superhumans, right? Superman didn't push a bunch of buttons into a screen before leaping off into flight. He just jumps in the air, and his powers take over and amplify and extend that ability. And that's exactly what this type of technology does for humans. It amplifies and extends our natural interactions with the world in astronomical ways. So my question is to you, what will you do with your superpowers? Thank you.
Do you feel as a superhuman?
Not yet.
Not yet, but you will.
I will.
So that's the future ahead of us.
Oh, yes.
Jody Medich, thank you very much.